Hi, and welcome to the fourth lesson of Mr. Cohane's online lessons. This one is dealing with terminating and repeating decimals. Please make sure you have your worksheet in front of you as well as a pencil. First thing we need is definitions. So, pause the video right now. I'm going to step away and copy down the definition of a rational number. Rational numbers are any numbers that can be written as a fraction. For example, 1/2. 1/2 is a rational number. How do I know? Because it's written as a fraction. Well, what about a number like 8? Is 8 a rational number? Well, can it be written as a fraction? If it can, then it's rational. And yes, because 8 is just equal to 8 over 1. What about a number like 5/10? Well, that's also a rational number. How do I know? Because it can be written as 5/10 as a fraction. So any number that can be written as a fraction is considered rational. Next on your worksheet is I give you a heading that says rational numbers, integers, and whole numbers. So what I want you to do is make a bullseye with 1, 2, 3 rings. And the outside ring we're going to label as rational numbers. And then what I want you to do is I want you to put 3 examples of rational numbers. My example, again, if it can be written as a fraction, it's a rational number. So I'll pick 13/27. It's rational, can be written as a fraction. Next I will pick 7/100, another rational number. And one more rational number, I'll pick the number 8. Again, because it can be written as a fraction. Rational numbers is a very, very big set of numbers. And a smaller set of numbers are our integers. So, your middle ring, I want you to label as integers. And then I want you to write down 3 examples of integers. Remember, integers, positive, negative numbers, and 0. No fractions, no decimals. I'll pick a -13. I'll pick 12, and I'll include 0. Those are my integers. Next, an even smaller set is our whole numbers. So, in your middle, I want you to label whole numbers. And then give me 3 examples of whole numbers. I will give 12, 15, and 1. Whole numbers, positive numbers. Those are our whole numbers. So as you can see, rational numbers are the biggest set. Integers are our next biggest set. Whole numbers are the smallest set. Those are our positive numbers. Next, though, we have repeating decimals. Every once in a while, when we were converting fractions to decimals, someone would say, Mr. Cohane, what do I do? It's just going to keep going on and on and on and on. Well, that's called a repeating decimal, and that's what we're going to work on today. Write 5/12 as a decimal. So, here's what we'll do. 5/12. How do I turn that into a decimal? Divide the numerator by the denominator. So in this case, 5 is going to go inside the house, divided by 12 outside the house. Now looking at this right away, 12 goes into 5, it can't. So what do? Annex the 0. But before we annex the 0, have to remember to put that decimal point. And as soon as you put it there, I bring it right up top. Then I annex my 0. Now that looks a little bit better. 12 goes into 50. How many times can 12 go into 50? Well, it doesn't exactly go in evenly, but the closest is 4. 4 times 12, 48. Subtract. 0 minus 8, you can't do it. 5 becomes a 4. 10 minus 8 now is 2. 4 minus 4 is 0. Perfect. Now I look again. Annex the 0. Bring it down. 12 goes into 20. Well, it doesn't go in evenly, but the closest is once. 1 times 12 is 12. Subtract, and we are at 8. Okay. Annex another 0. Bring it down. How many times does 12 go into 80? Well, it does not go in evenly, but 6 times. 6 times 12 is 72. Subtract. 80 minus 72 is 8. Okay. Annex another 0. How many times does 12 go into 80? Well, wait a minute. We just did that. We did it up here. The closest it comes is 6 times. So it's another 6. And we know 6 times 12 is 72. Subtract, and we get 8. Now, are you starting to notice a pattern here? Are you starting to notice that if we just kept on going, we would keep finding 8 and 8 and 8, and we'd annex more and more zeros, but still we would keep getting 6, 6, 6, 6. That is what is called a repeating decimal. Now, how do I write a repeating decimal? Well, 4, decimal point 4166, and we know it will go 6 and 6 and 6 and 6 and 6 and on and on and on and on and on. So how do I write it? Decimal point 416. Now, because the 6 is the part that would repeat and on forever, you draw a little bar over the 6. What that tells the mathematicians out there is that 5/12 as a decimal is decimal point 416 repeating. Okay? How do I know it's repeating? Well, because I put that line above the 6, and that says that it repeats on and on and on. Okay? Let's look at another example. Let's look at what is negative 2/9 as a decimal. Again, we set it up the exact same way that what we did before. Negative 2/9. We have to remember that. Don't forget that negative symbol. We know the answer is going to be negative. So, divide the numerator by the denominator. 9 can't go into 2. Put my decimal, I put my decimal, annex a 0. How many times does 9 go into 20? Well, the closest is 2 times, because 2 times 9 is 18. Subtract. 10 minus 8 is 2. Perfect. Annex another 0. Bring it on down. How many times does 9 go into 20? 2. 2 times 9. Starting to think there's going to be a pattern. 2 times 9 is 18. Subtract. 20 minus 18 is 2. Let's annex another 0. Bring it down. 9 goes into 20. 2. Are you starting to see the pattern? The repeating is going to be 2. We could go on and on and on and on forever and ever and ever, and we'd keep getting 2, 2, 2, 2. This is what, again, is called a repeating decimal. Remember, it was a negative 2/9. So the answer is going to be negative decimal point 2 repeating. That 2 is the part that repeats, so it goes on and on and on. Negative 2/10 repeating. So 2, and got to remember to put that bar above the part that repeats. Okay? That's going to conclude repeating decimals. Again, have this worksheet filled out. Bring it to class with you. That's going to be your ticket to the group. We'll catch you next time.